Alright, so in this example we have two blocks, A and B, which have masses of MA and MB respectively, and the blocks we're told are initially moving to the right and left respectively on smooth horizontal surfaces with speeds of VA1 and VB2 respectively, VA1 and VB1 respectively. At some instant in time, we're told A strikes B, and that the coefficient of restitution for this impact is given by the value E. As a result of impact, we're told that block B becomes stationary. Based on this information, we're asked to determine the initial speed of VB1 of block B. Okay, so to help us out here, we're going to note that I'm going to want to treat this as a system of particles, and so if I draw a quick free body diagram here, it's going to be rather anticlimactic. We're simply going to have the total weight of the system, MA plus MB acting down, times G, and we'll have some net normal force acting up. The key takeaway from this is that in the direction of n, the direction normal to impact, we have no forces. And so in this regard, we know that linear momentum is conserved in the n direction. So if we exploit this fact, I can say that the initial linear momentum prior to impact in the n direction is given by the mass of block A times its initial velocity in the n, which is VA1, plus the mass of block B times its initial speed in the n, which is minus VB1. And then we're going to have this is going to equal MA times VA2 plus MB times VB2. Now in this case, if we read the problem statement carefully, we're told that post-impact, block B becomes stationary, and so that means of course that VB2 will go to 0. And so we can use this to find one relationship between the speeds of the objects pre and post impact. Now in addition to this relationship, I can apply the impact rule, which I sometimes write short as IR, and this tells me that the coefficient of restitution E is equal to the distance of velocities post impact, so I can write this as VB2 minus VA2 divided by, in this case, VA1 minus VB1. Again, I'm going to note that post-impact, the speed of block B is 0, and so this is going to give me that minus VA2 is equal to E times quantity VA1 minus VB1. If we look carefully, calling this equation 1 and this equation 2, we realize that we have two equations and two unknowns, and so we can take this information to extract the answers that we seek to find. I'll leave that up to you to do since it's a purely numerical exercise. I know you got it, everybody. Best of luck. Take care.